In this lecture, we will discuss about 16.1, how to solve line integral. So line integral is different from double integral because in this integral, you have to integrate with respect to ds. Now, what is ds? If this is the arc, then the arc element is ds, right? So ds is neither dx, neither dy. It is ds is the arc element. Arc is r theta. So how to integrate a function which is on x and y, and we have to integrate it along with ds. So the formula is given. This is the formula. This is the formula. This one is the a function over curve C, right? So first step, we need parametric equation, that we have a position vector whose x component is representing x as a function of t, and its j component is representing y as a function of t, and its k component is representing z as a function of t. So with the help of this equation, we convert x into as a function of t, y as a function of t, and z as a function of t, right? So first of all, we need the parametric equation. Second, this is the formula of line integral. You have to learn this formula. We have to convert this given integral in this form. So there are three divisions. First step, to convert x, y, z in terms of f of t with the help of this transformation given in the question. And then you have to transfer ds, which is equals to velocity and dt. So this is step number 1 and step number 2. Now we do the problem. Now we do the question from the exercise, and we take question number 9, exercise 16.1 and question number 9. So I write down the question. Now we will do question number 9. So according to the formula, step number 1, we want parametric equation. So this is the x part, this is the y part, and the z part. So the x part says the I component is t, and the y component is 1 minus t, and the z component is 0, right? So from this position vector, we find velocity, which is the derivative of r with respect to t. So the t derivative is 1, I. 1 minus t derivative is minus 1, j, and it is 0. Now, velocity magnitude. So magnitude of any vector is calculated by taking under root and square of each term. 1 square minus 1 square, it becomes under root 2, right? So in this way, we calculate ds. ds is speed time, velocity time dt, and it will be under root 2 times dt. This is the first step. In second step, we have to convert this given function x plus y, the function, into f of t. The function is given x plus y. So according to the position vector, the x component, the I component is t, and the jth component is y, 1 minus t. So when we solve this, I get 1. So I have to transfer this and ds, right? So ds is this and x plus y is this. Now the third step is limit of t. Since t is equals to x, so x varies from 0 to 1 in this question. So t varies from 0 to 1. So these are three steps. Now I use three steps in the integral to evaluate the integral. So the integral is x plus y ds and c. So we converted, c will be converted to limit 0 to 1, x plus y will be converted to 1, and ds will be converted to under root 2t. Now you will integrate it. The answer is t from 0 to 1, and it is 1 under root 2. So all the question from exercise 16.1 will do by these steps. First you take the r, and then you take the velocity by taking derivative, and you take the magnitude, and this will be ds. Then you come to step 2 and see what is the function given inside the integral. Take the function and convert it into t. X component is the I component of r. Replace x with the t. The y component is the j component of r. Replace it with this. And now, and then step number 3, take the limit. X is equals to t, and this is the limit. When x is equals to t, so in from the point from to 2, x is varying from 0 to 1. So as x is equals to t is varying from 0 to 1. So I take all of the things and just convert this integral in this form, right? So this is 16.1.